Next up, we have Arnav Kapur. Arnav is a research in the Fluid Interfaces group at MIT Media Labs. And so he's got a very interesting presentation. As we get ready for him, I ask that there are lots of seats up here, and we're going to be here at least for the next 45 minutes to an hour with the rest of the speakers. So please come on up. There are many, many seats on both sides. So please have a seat, because we've got to have not just Arnav, but Sunil after him as well. So Arnav, you ready to take on? Come on.
All right. Thank you so much for that introduction, and it's awesome to be here at NASSCOM. I'm going to be talking about intelligence augmentation. Before I do that, I'm going to take a trip down history lane and talk about history of computing in general. This is the first ever computer. This was designed by Charles Babbage, and it was called the analytical machine. And what it did was, it did a bunch of calculations. It didn't function as well as he would have liked. And then we moved on to mainframes in the 1950s. After that, desktop computers in the 1980s, smartphones after that. Now we have voice assistants, Alexa, Siri. And this is our imagination of the future. Robots wrapped in gold metal talking to us in weird languages. All the computing devices that have existed up till now have always been these extrinsic devices, these external machines that we interact with, we type on. And there's a thought, could we flip this approach? Could we, instead of considering the computer to be an extrinsic object, could it be more an intrinsic object? Could it be a part of human condition and a part of human personality? So when I talk about intelligence augmentation, my goals are twofold. The first goal is, can we weave AI, computing, and the internet within human beings as an extension of our brain directly? Second is, can we combine human intelligence and AI and build the next generation of personal computing? I like to think of this as inserting a chip in our brains. Of course, without drilling a hole in the skull. I've been told people don't like that. But another analogy is today's smartphones are like monocles. You have to take them out for different applications. You type on them. I was at the airport yesterday at Bangalore, and this woman was pushing a pram while on her phone. And she pushed it like a few inches so that the pram would run on its own while she was on her phone. And this is exactly what we don't want. I think of tomorrow's personal devices as sort of contact lenses that you put on, you don't feel it, it's part of you, and once you put it on, you're using it throughout the day, and you put it off after some time. To design the personal computing platform of the future, my belief is that you have to take a human-centered design approach, which is you have to think about design principles that are important to build this kind of technology. And I'll list 5 of those here. One is, if you build something that functions as an extension of your brain, the interaction should be private and seamless. Today, when you're calling someone at home, everyone in the vicinity sort of hears your conversations. When you're typing on a screen, the interaction is not private. So can we make some interaction that is private and seamless? It's very important to build a system that's non-invasive. So you don't want to interface to the brain directly. That wouldn't scale. You want to build something that you could put on where and that senses your intention non-invasively. A very important parameter or design principle is that the system should be non-intrusive. It shouldn't pick up on your private conversations, your private thoughts. One sort of thought experiment is if we design a BCI, a brain-computer interface, and somehow the device has access to your thoughts, and if Facebook, say, tomorrow sells it to third-party companies, that wouldn't be ideal. So you want to build a system that is non-intrusive. Fourth principle is it should be high bandwidth. Today, when we type on a keyboard, it's extremely slow. It's a very slow interaction. You want to have an interaction that is a high bandwidth interface that takes in a lot of information from the human user, gives back a lot of information as well. And the fifth principle is that the interaction should be voluntary, that at all times, the human user should be in control of the interaction. So based on these 5 design principles, we at MIT designed the system called AlterEgo. And what the system is, it basically measures tiny neural signals that the brain sends to your speech muscles. So when you're actually speaking to yourself internally, the brain sends these neural signals to your speech muscles, and the extension on the jaw actually picks those signals up. So without voicing anything, without moving my muscles, without doing anything observable action, the computer can construct text or translate text from just me internally speaking. So instead of reading from the brain directly and making an intrusive system, we pick up from the speech system. So it's more like, I often think like thinking and speaking is not binary, it's more of a spectrum. Thinking is a private activity, but you're not in control of it a lot of the time. Speaking is not private, but you're in total control over what you're speaking most times. But internal speech is somewhere in the middle. It brings the best of both worlds. You're in absolute control over what you're saying, but it's also completely private. There's an AI running in the cloud, so it picks up these things that you're saying to yourself, and it translates that into applications. For example, if you want to light up lights in your room, so it basically translates that. There's a natural language processing engine that translates that command, and basically it switches on lights. So this AI actually functions as an extension of your brain, in a sense. And then the AI transmits audio through vibrations in your skull and into your inner ears. So without blocking your ears or without distracting you, without unplugging you from your environment like today's smartphones do, there's an I/O with the human user without disrupting any perception of the user. So without blocking the ears, the person gets audio feedback. And the combination of these technologies basically makes the subjective experience. You feel like you have Google in your head, basically. That's the idea. So you have a voice assistant that's inside your head that you can interact with. So the technology disappears, and what remains is a magical experience. And it's sort of different, right, this model. This has been the computing model for over half a century. You have a device in front of you, interact with it. The flip is, could you have an extension of a person that is a passive interaction, always in an input and output, but you're interacting with the world. You're not on a smartphone interacting with a device. It's more like the smartphone as an extension of your head, constantly augmenting you. If you want to search for something, for example, Google something, you can Google it, it'll tell you the answer through bone conduction without you taking out your phone at all. So I'll show you a quick demo of what the device does. This was a live demo on television. I'll just quickly play it.
What is 45,689 divided by 67?
Sure.
He silently asks the computer and then hears the answer through vibrations transmitted through his skull and into his inner ear.
6, 8, 1.9, 2, 5.
Exactly right. One more. What's the largest city in Bulgaria, and what is the population? The screen shows how long it takes the computer to read the words that he's saying to himself.
Sofia, 1.21 million.
That is correct. You just Googled that.
I did.
You could be an expert in any subject. Mm-hmm. You have the entire internet in your head.
That's the idea. So what I did there was I Googled the capital of Bulgaria without moving anything, without voicing anything, and without using my hands at all. So it felt like I have Google in my head. I have knowledge of the internet in my head. The first example was me computing a complicated arithmetic question. So the idea is if you put this on, everyone can be good at math. If you can crunch any sort of numbers. I'll show you another video of what this device does as a mobile computing platform. Of course, this is a prototype. This is not how the final version hopefully would look like. But this is the first generation of what we built. Yeah.
(10:43 a.m.) Total $10.07.
Another application that you could think of is telecommunications, right? Could you actually have a telepathic conversation with someone else instead of our usual phone conversations that we have today? I'm going to show you a quick example of that. This is me silently texting someone else.
Your reply was sent.
So without typing anything, without voicing anything, I can send text messages. So, I mean, you can think of a lot of applications. You can think of whatever your phone can do. I often feel like we're already cyborgs. We have more computing power today than the NASA team had when they were sending the Apollo missions on the moon. And we constantly look up information. We constantly access this computing power at all times. But what if we could actually integrate humans and computers to unlock abilities like never before? Another area that I'm really excited about with this is how you can closely couple human intelligence and AI. An example of this is in the medical space. So upwards of 5.2 million deaths occur in India due to a medical error. And this is a global statistic. So after cancer and heart disease, medical error is the third leading cause of death in the US. And the World Health Organization says that it's in the top 10 leading causes of death. So could you imagine a situation where a doctor has a patient in front of her and she is trying to diagnose the disease? So she could internally have the system on, internally vocalize what the symptoms are. This is transmitted through an AI running in the cloud, and this AI could be trained on millions of medical records, and it sort of searches through all medical diseases, what the diseases could be, and gives back information what the AI thinks the diagnosis could be. So you have the doctor there with the patient, and you have this human-AI collaboration happening, and that could, in my belief, significantly improve diagnosis and prognosis. And this, of course, will translate across domains. And this is what I imagine such an interface could do. Another area that I'm really passionate about applying this technology to is enabled communication. There are lots of these speech pathologies, lots of these conditions, cerebral palsy, autism, ALS, stroke patients who are unable to speak. I was at a hospital recently with a stroke patient and was a wheelchair-bound patient. And what the way he communicated was the nurse used to hold up a sheet of paper, and that had letters, the way our old phones used to have, ABC on one side, DEF. And the patient would twitch his muscles to indicate one of the groups, and it would take about 25 minutes to get one word out. And those are the methods that are being used today. And I feel like we're losing out on their ideas and thoughts because it's so frustrating for the patient to communicate. So something like this, I believe, could enable real-time communication for those people, allow them to talk the way we do, the way we converse. And this translates to a lot of other conditions as well, oral cancer, stuttering, cleft lips, and so forth. And you can imagine that there are lots of different domains that this technology could apply to. If you talk about personal computing in the future, you have memory augmentation as well. You'd never be able to forget anything. Could you internally record stuff that you want to remember and never be able to forget it? Language translation. Could you internally say something in one language, get the translation in your ear, or connect it to a Bluetooth speaker and ask the AI to translate it for you, so you don't have to learn a second language anymore? Also, Parkinson's, ALS, other services. For example, you could have third-party apps on top of this platform, anything you could imagine. So quickly, I want to wrap up the way I started. So we had the analytical machine, Charles Babbage. Then we had mainframes in the 1950s. Desktop computing came on in later. Then we had mobile computing. And I think the future is human computing integration. And if you could see, these machines kept on getting smaller and smaller, and the interaction kept on getting more intimate with humans. I think the future is closely coupling humans, AI, computing, and the internet. And I hope AlterEgo plays a part in that future. I just want to leave everyone with one thought. I think humans coupled with AI will empower us. I think as debate rages on about AI versus humans, I think the conversation of the future is more about how we can couple human intelligence and AI intelligence. And I think that will unlock our potential like never before. So thank you. Thank you for listening.
We can't let you go without a couple of questions.
Sure.
So a couple of questions for Arnav. Yeah, well, up here, please, a mic up here. Yeah.
So I just want to ask you a question.
Sorry, the lady has the mic.
Okay, in your system, since your system is built on speech system,
Yes.
is there a possibility where your system can degrade if this speech system is not working? I'm not aware if this is a possibility, but I just asked.
Speech system of the person, if the speech.
Yes, yes.
So it's more of a spectrum. So I think even if you have very severe, for example, a motor neuron disease like ALS, some of the motor neurons are still functioning. Our speech system is the most complicated neuromuscular system in our body. There are over 100 muscles in the human body. But not all of them die out, or not all of them are impaired. Some of them are still functioning. Most of them are not. So something like this could actually take subtle signals from that and construct speech out of that. And that's the hope.
The lady next to you.
So I've actually been and seen the MIT Media Lab, and it's mind-blowing, absolutely amazing work that you guys are doing. My question was, this looks fabulous. How accessible is it and how affordable is it? Like, I mean, and when can we expect to kind of see it and hold it and touch it and use it?
It's not a...
What is the work that you did on that? And one more part of the question is that for OCR to come into production, it took a long journey.
Yes.
Where are we in terms of understanding the signals and converting into human understandable words?
You're talking about in terms of silent speech?
Yeah.
Yeah. Yeah, so the first question was about converting the signals and what kind of techniques we're using. We're using a machine learning AI pipeline to translate neural signals into text.
Yeah, my question was,
Yeah,
how did you get the data?
Data is we're conducting our own experiments. So speech recognition, as you know, there are a lot of data sets online available. Something like this, it's a new modality, nothing is available online, so we can't train it. So we conduct our own experiments. We bring in a lot of people, sort of ask them to sit down and speak a lot of words in a day and frustrate them. But we're collecting our own data. We're building our own data set, and hopefully we also want to distribute this to other labs, other organizations, so that they could conduct experiments with this as well, and so we could build a better system.
And last thing.
Yes.
Humans and missions, I am with Technium.
You're with?
Technium.
Okay.
Yeah.
Great. Any other questions? There's one back there. If we can get the mic over there, please.
Yeah, nice to see this product. Actually, my mom suffers from motor neuron disease. And I was just thinking, like, how can I get access to this so that I would love to see her use this and communicate.
We're moving ahead with full steam. We're actually working with hospitals right now. It's not a deployable technology yet. I think we still need to perfect it. This is the first iteration, but I would love to speak to you afterwards.
Okay.
And
sure, I would like to see if we can use it to test the product and help you. Yeah.
Arnav, thank you so much again.
Thank you so much.
Appreciate it. Great work.
Let me give you a little gift.